All right, welcome to the lesson on the sound barrier. So what's today's goal? I should be able to explain phenomena like the sound barrier, sound intensity, and the Doppler effect. I want you using proper terminology. Now, just as a heads up, this would normally go over 2 days, the lesson. So there will be probably 2 or 3 videos here, and then it's going to take a little bit of time to get through the homework. So, but normally, like I said, in a regular classroom setting, I would have taken 2 days to get through this. So, the term sound barrier, what it does is it describes the buildup of sound waves in front of a fast-moving object. Now, sound waves, again, are a series of compressed compressions and rarefactions. So they are getting sort of squished together in front of the object. They're kind of pushing it along, or it's like pushing from behind a couple of people ahead of you. This happens as the object's speed increases and begins to catch its own sound waves. All right? So let's take a look at sound waves for a second here. So if we have a stationary object, your sound waves are going to be concentric circles. You're emanating sound in all directions. All right, so your sound waves are heading outward. If you're moving, all right, what happens is those concentric circles, you start getting closer and closer to the front of them. So we end up with circles that start looking like this. So you're not in the center of the circle anymore. You've kind of moved to the right a little bit in terms of the object. All right. And now finally, a fast-moving object, if you're moving close to the speed of sound, that means that you are right on the edge of the sound you're producing and the sound that you've already produced. So you end up having sound waves that start looking like that. And this is where we're talking about that buildup, okay, of sound waves. So the buildup of waves. All right. So we're going to come back to that in a second then. So as an object reaches the sound barrier, there is an enormous pressure buildup, and that's that zone right here that I have circled. Okay? You're pushing all that air in front of you, you're compressing it, okay? And what's happening is those air particles are getting sort of squashed together, the same as if you are pushing from behind, pushing a bunch of people. So in order to break through that barrier, you need a huge amount of energy to break through, and that's why the aviation industry is researching better and more efficient A design and B engines, because in order to rip through that, you need a lot of power. So the aviation industry has never had a shortage of energy. Okay, they've always been able to build very powerful, big engines. The problem is humans couldn't fly planes that are being pushed that fast, so they need that technology. So what happened was they moved away from wings that looked like this on planes, like your biplane. That's a terrible plane. I can hear people laughing at me about that one. So wings that look like this on a plane to sort of that sweep triangular delta design, all right? Or the wings that kind of look like this on the planes. So they get that sleek, swept back look, okay? That allows for a more aerodynamic design. It decreases the amount of pressure buildup in front of them, and it also allows them to maintain control at high speeds. Okay, so they went to this new design, or moved on to the new design. So what I have here, I have an applet that you can try when the video is done. And for now, I'll just draw it as best I can. So the sonic boom or sonic shock wave is the result of an object moving or traveling faster than the speed of sound. So what's happening is you're leaving a pressure wake. So down here, we can say similar to a boat. Similar to a boat in water. What happens when a boat goes by? Okay, so if you think of yourself on shore, so here you are on shore, and you see the boat. So we'll go with stage 1 and the boat stage 2. At stage 1, the boat's going to go by, but you're not going to see the wake on shore when he's across from you. You're actually going to see the wake strike the beach when it's gone by. Okay, so that's the wake. Well, when you hear the sound barrier broke, when you hear that huge sonic boom, the plane's already by you. It doesn't occur when the plane goes over, it occurs when the plane has gone behind and left that trail. So similarly, what's happening on that plane is that we have a huge pressure buildup of particles. So the plane's traveling, and all of these particles are building up in front of the plane and at the tips of the wings. So we have all these air particles being compressed together. Now behind the plane, what's happening is because those particles are being pushed along, there's less pressure behind the plane because there's less particles. So low pressure, or less pressure I should say, it doesn't matter. And here you have your high pressure. Okay, so you have your buildups. What happens then as the plane breaks through, or kind of cuts through that barrier, we get what we call a pressure equalization. So when the plane we'll go with breaks through the buildup, a pressure equalization occurs. Pressure equalization occurs. But that ripping through the particles is what causes that boom. So ripping through the particles causes the sonic boom. Okay? So as that plane finally tears through that barrier, it's like you pushing against a rubber barrier. So you're running and you're pushing against it, all of a sudden you snap through. That rubber band that you broke through snaps, and you hear the snap. That is that sonic boom that occurs. And similar to the boat, then someone seeing that plane flying overhead. So copy that for a sec. Paste it a little bit smaller. So someone on the ground, okay, you're going to hear that sonic boom like the wake of the boat. All right, so that cone, it creates a cone in that leading edge. When that sound reaches you, that's when you hear that sonic boom. So you'll see the plane before you hear that sonic boom. So the 4 stages then. So we'll talk about the stages that the plane will go through. So at 0 meters per second, plane is in the center. So it's on the ground idling. Okay, so the noise is emanating outward from it. All right, in all directions. So the plane is now in flight in stage 2, but we're less than Mach 1. So we're slower than the speed of sound. And the waves in front of it are a little bit more compressed. Now what does that mean out front? Okay, that compressed waves really means those waves out front that are compressed, that means that there are crests hitting you faster at a higher frequency. So if it's hitting at a higher frequency, the pitch of the plane will be much higher. Whereas behind the plane, there's a larger distance between wave fronts. That means the frequency is decreased. So that means it'll be a lower pitch. All right, so low pitch, and over here would be a high pitch, because those waves are getting to you faster and faster. What happens at Mach 1? So what happens when the plane reaches the speed of sound? I showed that previous diagram already. So your circles all emanate from that point source. And finally, what happens when the plane breaks through? Well, the plane is now traveling faster than the speed of sound. So that means that it's outside its initial circle. So there's the sound it just created, and it's already passed through or outside that. And what happens is then we get concentric circles that are getting larger and larger, something like that. And that's kind of how the sound is emanating outward, but the object is leading or is ahead of the sound it's making. Okay, and there's that kind of leading edge when the sound wavefront, when it reaches the person on the ground again. So you don't actually, for a plane going faster than the speed of sound, okay, it's going to be it'll be far past you by the time you actually hear it go over. So there we are. So Mach 1, this is when that sound barrier is broken. So sonic boom occurs. Okay, and there we are. So let's talk about sound intensity for a second. So similar to water dissipating, okay, the waves, they get less and less as they go outward. Sound waves are the same idea. So the intensity, I, of a sound wave is the rate of power, and we talked about power in Unit 3. Okay, so the power of the source passes through an area. Okay, area is the other component, perpendicular to the wave. So we end up with the formula I equals P divided by A. Now, in a real world, if I have a suspended object, we say that sound wave would look like this, but remember, it's 3D. So it would actually be a spherical sound wave that's being produced. So if that's the case, this formula would have to be adjusted a little bit, because it's not the area of a circle, it's the area of a sphere, which is 4 pi r squared. All right, so there is our intensity for an object. And if I do a quick unit analysis for you here, power is measured in watts, and area is in meters squared, so intensity is watts per meter squared, so that's what you're feeling when you're talking about that. All right, so comparing two intensities. So if I look at comparing two intensities here, I'm just comparing the two formulas. So if I do a ratio of I1 over I2, I would equal the power for an object over 4 pi r1 squared, excuse me, divided by the power of a new distance. So basically I'm changing distance here. Okay. I'll note that. So same power, different distance. So we're looking at, we've moved away from the sound source. Okay. So what happens is we keep it as I1 over I2 on the one side of the formula. We have a fraction over a fraction, so we know how to deal with that. We flip and multiply by the reciprocal. And then from math, we know that inverse operations, powers would cancel, 4s would cancel, pi's would cancel. So all of that information is actually irrelevant. If you're comparing two intensities, it's simply the new distance squared divided by the original distance squared. So there's your first formula relating the intensity of sound. So R1, original distance, and R2 is your new distance. All right, and I'll finish this note up in the next video. Gives you a chance to take a break here, and we'll go from there.